In this video, we're going to talk about exponential functions. So exponential functions are functions of the form y equals b to the power of x, or x is in the exponent. The variable x is in the exponent. That's why it's called exponential function. Now, the definition says that the base b is called the base and x is called the exponent. The base b cannot be equal to 1. And it always has to be positive. B has to be greater than 0. And the exponent x could be any real number. Okay, it just cannot be imaginary, it has to be real. So these are the conditions for the definition of an exponential function. So if you look at the number line, if this is 0 and if this is 1, what we understand from this definition is b cannot be 1. So this point 1 cannot be in this function, okay? But b can be greater than 0, so you can have this space in between here. That means all the fractions that go between 0 and 1, fractions like half, 1/3, 2/5, all 0.5, 0.6, all those kind of fractions. Okay, 0.6 is a fraction that goes between 0 and 1, right? So all the fractions that's between 0 and 1 but cannot include 1, and everything that comes after 1. So without 1, everything that comes after 1 till infinity, as long as b is positive. So those are the restrictions on the functions over here for the definition. Okay, so let's quickly look at the shape of this function. Let's randomly look at the exponential function where y is 2 to the power of x. This is the most basic and most common exponential function. So let's plug in, instead of x, let's plug in -2 and let's fill in this table first. So when you have y is equal to 2 to the power of, instead of x, if you plug in -2, we know that negative exponents are written as a fraction in the denominator like that. Okay, 1 over 2 to the power of 2, which is really 1 over 4, because 2 square is 4. So the first answer is 1 over 4. Then when you have x is -1, you can put y is equal to 2 to the power of -1, which is 1 over 2 to the power of 1, which is really equal to 1 over 2. So when you put -1, you get 1/2 as the answer. 0. When you put x is 0, you get y is 2 to the power of 0. We know that any number to the power of 0 is 1. So for 0, it is 1. Next one, 1. Plug in x as 1. 2 to the power of 1 is just 2. Now plug in x as 2. 2 to the power of 2 is 4. Now plug in x as 3. 2 to the power of 3 is 8. So these are our coordinate points. Let's quickly graph them. So when it's -2, it's 0.4, which is like somewhere over here. When it's -1, it's -1/2. When it's 0, it is 1. When it's 1, it is 2. So I have to go up to there. When it's 2, the answer is 4. So somewhere up till here. When it's 3, it is 9. So somewhere up till there. This graph, and let's see what we got. So that is the graph of y equals 2 to the power of x. Now let's talk about some properties of this graph. See that the domain is from -infinity to positive infinity, which is the value x values. The range is just above the y-axis. This graph is not going below the y-axis. So the range is from 0 to positive infinity. The y-intercept, where it touches the y-axis, is the point 0, 1. So we're going to put 0, 1 as the y-intercept. If you look at this graph, is this increasing or decreasing? How do you decide that? You always look at a graph from the left towards the right. As you go towards the right, this graph is increasing. So this is not decreasing, it's increasing. Horizontal asymptote. Horizontal asymptote is the x-axis. There is no vertical asymptote here. Is this function continuous? The sixth one. Yes, this is a continuous function. Okay. So these are the 6 properties. Now let's talk about some more about this. what are the transformations of the graphs of exponential functions? So the first one is, if you change this x to negative x, what could happen? So 1 and 2 has to do with reflections. They're going to reflect. This is going to reflect over the y-axis. If x changes to negative x, it's reflecting over the y-axis. And if you have a -1 or a negative before, the graph is going to reflect over the x-axis. So these are both reflections. Now if you have a plus or minus n, for example, if you have y is equal to 2 to the power of x plus 1, if it's a plus 1, it moves to the left. Plus n moves to the left and minus n moves to the right. Okay, n is just any random number. So if it's a plus 1, it'll move 1 block to the left. If that was a minus 1, that would, like for example, y is 2 to the power of x minus 3, means it will move 3 blocks to the right. Here, you may already guess it. If you have y is equal to 2 to the power of x plus 5, what could happen is it'll go up 5 if it's positive, if m is positive, and it will go down 5 if m is negative. If this was a minus 5, it will go down 5. Next is the natural base, or Euler's number e. The only difference is that f of x is equal to b to the power of x. Instead of the base b, they're using a number called the natural number, which is e, 2.7182, and it just goes on. It's actually a decimal that does not end. I hope you remember what you call a decimal that does not repeat or does not end. It's called an irrational number. So e is an irrational number here. And it's also called the Euler's number because he's the mathematician who found that number. Now this is only used, you don't have to worry too much about this. It's, even though it looks like a number that doesn't end and doesn't repeat, it's not confusing because the calculator will do the job. All you have to do is plug in numbers, get the answer from the calculator. Now this is used to find amount for continuous compounding. For example, if you put, this is an example here, the formula is a is equal to p e to the power of r times t. What each letter stands for is written on the left over here. A is the amount, p is the principal, means the first money that you're putting in the bank, r is the annual interest rate, t is the number of years that you put the money in the bank. For example, if p is 12,000, if you're going to put $12,000 in the bank at a rate of 3% interest, annual interest, for 5 years, t is 5 years, at a continuous compounding rate. If it's continuous compounding, how much amount is that? So to find the amount, all you have to do is, instead of p, plug in 12,000, e to the power of 0.03 times 5. 3% is converted to a decimal, it's 0.03. If you don't know how to do that, you have to do 3% is really 3 over 100. So that's how you change it to 0.03. That's how I get the 0.03. So instead of r, you plug in 0.03 times, instead of t, you plug in 5 because t, or the number of years, is 5. So once you put it in the calculator, you get your answer as 13,942.01. So you only have to do these kind of problems for you're using the natural base, or e. Next is exponential growth and decay. So what you need to know about that is, we know that when you have the exponential function y equals b to the power of x, b can only be positive, and it has to be between 0 and 1. It cannot include 1. 1 is not allowed in here. 1 is not allowed here. And it has to be greater than 1. Less than 1, greater than 1, but not including 1. And you cannot have any of the negative numbers for b, right? So whenever b is less than 1, between 0 and 1, like fractions like half, 1/3, 2/3, 5, 2 over 5, 7 over 5, those kind of fractions, it's going to be exponential decay. Whenever b is a number greater than 1, like 2, 3, 4, 5, 20, 500, positive numbers greater than 1, it's going to be called exponential growth. So here are some examples. Let's just quickly see what this is. Here b is 2, which is greater than 1. So this is the exponential growth. This is b is less than 1. So this is decay. This is e. Euler number is 2.71, which is greater than 1. So that's also growth. Here pi is 3.14, which is a number greater than 1. So it's also growth. 2/3 is a decimal. It's a number less than 1, positive number less than 1, so this is decay. So some examples for growth and decay. Now the main formula for this chapter is the next screen. Formula for compound interest. So the amount is equal to principal times 1 plus r over n, the whole to the power of n times t. All you have to do is plug in numbers and do this in the calculator. It's not that hard. What each letter stands for, I have written on the side over here. A is the amount that you're going to get at the end. P is the principal, which is the amount that you put in the beginning, the initial amount, the starting amount that you put in a bank. R is the annual rate of interest. N is the number of compoundings that they're going to say it'll be compounded quarterly or compounded monthly. Okay, that's called the number of compoundings. T is the number of years that you put this in the bank. So let's see. Let's do an example problem. Let's say if the amount of money that you put in the bank is $12,000. Okay, $12,000 to start with is the principal, and the annual rate is 3%, and the number of years for which you're putting it is for 5. Find the amount that you're going to get if it is compounded quarterly. Now quarter means 4 times, so it's going to be compounded 4 times a year. So n is the number of compounding. So in here, since they use the word quarterly, you can say that n is 4. So let's figure this out. All you have to do is put it directly into your calculator, just like that. Write this out for now. So A is, instead of principal, I'm going to put 12,000 parenthesis 1 plus the rate. Change the rate to a decimal, 3%. We know 3% is, when you change it to a decimal, it's 0.03, correct? So instead of r, we can plug in 0.03 divided by, instead of n, we know n is the number of times it is compounded, which is 4 here, to the power of n times t. N is 4 times t is 5. So to do that, we have to actually put that in the calculator, just like that. And you get your answer as 13,934.21. Let's do what happens, question number 2. What happens if it's compounded monthly? Monthly means there are 12 months in a year, so n becomes 12 instead of 4. So you're going by the word. Quarterly means 4, monthly means 12, half yearly means 2, etc. So same thing, put it in the formula. 12,000 times 1 plus the rate is 0.03 still, but instead of 4 you're going to plug in 12 to the power of, instead of 4 you're multiplying with 12 times 5. 12 times 5. Put it in the calculator just like that, and you get your answer for the 12 months as 13,939.40. That's what you get when you compound it on a monthly basis.